So hello and welcome everyone. Welcome to this stream in which we are going to discuss the solution of yesterday's problem of the day. So basically we are going to discuss the solution for the problem of the day which was taken on 19th of June, and the name of the question was rearrange an array with order of one extra space, and the difficulty level which is mentioned for this question was medium. So let's first of all try to understand the problem statement, and then after understanding problem statement we'll be understanding the test cases. Over here in this question, at first if you simply read down the problem statement, you won't understand what actually the question is trying to say. We need to understand with the help of a test case. So basically let's understand what the question says. So given an array of size n where each and every element is in the range 0 to n minus 1. Okay, so every array element is from 0 to n minus 1, and what is the task? The task is to rearrange the given array so that the transformed array, that is array of t of I, becomes array of I. So this part needs to be understood with the help of an example. I will explain that part, and something over here is written in terms of nodes, that is array and the transformed array are both same variables representing the array before and after transformation respectively. So basically you are not supposed to create an entirely new array and return that array or something like that. You simply need to transform the current or the input array and change the values in your input array only. So that was a basic formal explanation about the question. So now let's understand with the help of an actual test case. So we simply need to focus on this part, that inside the transformed array at ith index, what is the value? The value is this. So let's understand with the help of a test case. So over here I have taken the same test case which is given to us in the input. This is actually the example number 2. Over here let's understand actually what the transformed array means. So it was mentioned that the ith index of the transformed array t of I should contain what? It should contain array of I, whatever is the value in the input array, and go to that index inside your input array and fetch the value present at that specific index. So we'll be focusing on this part, and I have taken this input test case in which the value of n is equal to 5, and these are the array elements. So let me write down the array elements: 4, 0, 2, 1 and 3. And it has been mentioned that the range of the array element is from 0 till n minus 1, where n is the size of the array, n minus 1. So this is the range, so we should not forget this range. And let me write down, this is my input array. So I'll be mentioning both the arrays separately, but you need to understand that this is not a new array. It is the same array which is taken as an input array, and these are the indexes 0, 1, 2, 3 and 4. So now in order to fill the 0th index for the transformed array, we need to focus on this formula. So that formula says array of I. So currently in the input array, what is the value present at the 0th index? It is 4. So what we have to do? We have to go to that index in the input array. So at the 4th index I can see 3. So 3 will be placed over here. So let's see the next index. So next index is 1. And what is the value at that index? At that index the value is 0. So what I have to do? I have to fetch the value at the 0th index. So at the 0th index I can see 4 is present. So in the transformed array at the index 1, 4 will be placed. So now let's see the next index. So the next index comes out to be 2. And what is the value at this index? The value is equal to 2. So what I need to do? I need to go to the index number 2 and fetch the value. So the value comes out to be 2. So now the next index is 3. So what is the value at the third index? I can see it is 1. So I need to go to the index number 1 and fetch this value. So at index 1 I can see 0 in the input array. So I'll be placing 0 over here. And the last index contains 3. So that means I need to go to the index number 3 in the input array. So at the index number 3 in the input array, the value is 1. So the last position or the 4th index will contain 1. You can observe this is the transformed array and this is what we are getting in the output. So both of them matches completely, 3, 4, 2, 0, 1. So basically, this is what the question is asking you to do. I have shown two different array, but you don't have to create any extra array and print that array. You simply need to modify the input array, and the task is to do that in order of one extra space. So from that it is completely clear that there is no requirement of a new array, because order of 1 can be only achieved if we save space or we use constant amount of space. I hope you were able to understand the problem statement. So now let's try to brainstorm and understand how we can actually solve this question. So what I'll be doing, in order to solve this question, I'll be giving you some of the observations. So first of all, the space complexity which we need to achieve is, so we need to keep in mind that the space complexity that the question says is order of 1. So how can you modify the array without using any kind of extra space? Even though you might have heard about swapping two integers, right? So in order to swap two integers, you were required to solve this question without a third variable. If this question was asked to you without using a third variable, it is very easy if you can solve this question with the help of temp variable, right? We know that technique. But this question can also be done in order of 1 time. So this was regarding swapping two variables, right? Swapping the value of two variables. Over here, you don't have two values, you are having an entire array. So this thing will be kind of trickier. Okay, so how will we do that? So before solving the question, actually this question is very easy if we know one technique. So what is that technique? So if you focus on the transformed array, the transformed array formula is very simple. You need to find the element present at the ith index in the input array and take that value as the index and fetch the value present at that particular index, right? This thing is very easy and it can be done very quickly. We simply need to write down in this in terms of code. But as we are not using an extra space, we need some kind of trick. So what is that trick? So let's say you are having a variable and that variable contains 3 initially, okay? And you have one more variable. That variable is, that value is equal to 4. So now what you have to do, you have to store this 4 and 3 in this variable. I repeat, you have a variable var and in that variable there is a integer value 3. Now what is your task? Your task is to store this value 4 inside the same variable. So I am asking you to store two different values at the same position or in the same variable. Let's say this variable is of integer data type. So let's say you were successfully able to store this integer 4 and 3 inside this variable. So if you are able to do so, you should be able to fetch 3 as well as 4 from this variable. So you somehow need to implement this part. If you are able to implement this technique, then the question solving becomes very easy, right? So I'll be explaining you how you can achieve this. So I was talking about this variable, right? A var, it already contains 3 and the other value I need to store was 4. So what I'll be doing, I'll be getting a value which is larger than both of this, which is larger than 3 and which is larger than 4. And in order to save some memory, I'll be taking the closest one which is larger than both of them, 3 and 4. So I'll be taking, let's say the value of n I'm taking as 5, because 5 is larger than 4 and 3 and it is the closest one. So now what I'll be doing, in order to store both the value, I know initially 3 is already present. So what I'll be doing, I'll be multiplying this value n with the new value. I'll be calling this as new element, and multiplication of n with the new element. And to this product, I'll be adding the original value of this variable. I'll be adding the original value. And whatever is the value of this equation, let's see what is the value, 4 into n, 4 into 5 plus the original value, that is equal to 3. So that would be 4 into 5 will be 20, 20 plus 3 will give you 23. So now I will be storing this 23 inside my variable var. So instead of 3, this variable contains 23. So I was somehow able to store this 4 and 3 inside this variable. But how will you fetch the original values? How will you get the first value and the second value? So first value was equal to 3, that means whatever was present inside my variable var, and the second value was equal to 4. So I need some kind of equation in order to fetch 3 and 4 from this variable. So in order to fetch the value of the first variable, that is 3, what I will be doing, you can observe over here the original value or the first variable, first value is present over here. So basically this equation is similar to the fundamental equation of division, right? This is nothing but the remainder. So basically what I am trying to say, in order to fetch the first value, I have multiplied this 4 with this 4 with n, that is 4 multiplied by 5, and to that I have added something. Something means 3 has been added, that is the first value. So what I will be doing, if I want to get 23 from the if I want to get 3 from this 23, I can simply apply modulo n. I repeat, in order to get the value 3 from this 23, I can simply apply modulo n. So that is 23 modulo 5 will give you 3, the remainder is equal to 3. So in order to get the first value, what you can do, first value can be fetched by simply applying modulo n to the variable. Now what about the second value? So second value, how can you get the second value? So if you divide the second value 23 by 5, you will be getting 4, right? If you take the integer division, 23 divided by 5, you will be getting the floor value as 4, or the integer division will give you 4. So the second value can be fetched by simply dividing the value of the variable by n. So this is the equation, and with the help of this equation you can actually store two different values in the same variable. With the help of this observation, you can easily modify the given input array in constant amount of time, right? Because the task was to modify the input array, and in the input array initially there are some values at each and every index. We cannot delete all those values because in order to store the other value, it is possible the original value will be required at some point. So I'll be taking the same example 4, 0, 2, 1 and 3, and with the help of this observation and with the help of this equation, I will be transforming this input array. So this is my input array, and what are the values? It was 4, 0, 2, 1, 3. 4, 0, 2, 1 and 3. So let me erase this part. And now what I will be taking as the value of n, and what will be the range of the array element. In the beginning I mentioned that the range of the array element is from 0 till n minus 1, right? And now over here, in order to get a non-zero value each and every time, because I am applying modulo n in order to fetch the first value, so the value of this n should be large enough, that means it should be larger than the other values var, right? So basically I know that all the elements will be in the range 0 till n minus 1. So now I will be taking the size of this array as my value n, that will be multiplied by the new element, and the original element will be added to that product. Okay, so now I am taking the n value as the size of this array. So size of this array is equal to 5. So now I will apply the modification on each and every index. Okay, so this is my index number 0. So the first step is to first of all find the new element. I am writing down the steps of the algorithm simultaneously, so pay attention. So first of all, in the transformed array, I need to find what is the new element that will be stored at the current index. Current index is 0th index, right? And I will be getting the new element by simply fetching the value at this index, at the index array of I. Okay, so this is the first thing I need to find, that is the new element. So after finding the new element, what I need to do, I need to store this new element in the index number 0, and 4 will not be removed from the index number 0. 4 and the new element, both of them will exist at the same index. So now in order to do that, I have seen a formula over here, right? So this was the formula. So this 4 is the new element, and this 4 is the new element. This 4 is the new element, and this is the original element, that is the element present at the ith index in the input array. Okay, so basically if I want to modify this equation into in terms of new element and the array ith element, I can write it in this manner. So that can be written as new element multiplied by n plus the element present at the current index, that is ith index, that is array of I. So this is the value which will be stored at the ith index in the transformed array. Okay, so this is the value which I will be storing at the ith index, and this value contains the new element that will be the part of your transformed array and the original value as well. Okay, so let's store this value. So at the ith index, what I will be storing? I will be storing new element multiplied by the value of n plus the original value which was already present. So this will be done for each and every index. So let's apply this equation for each and every index. So first of all, for the 0th index, find the new element. So that would be array of I, that is array of 4. At the 4th index I am having 3. Okay, so the new element I got is equal to 3. At the 4th index I can see 3. So now after this, what I need to do? I need to find the equation. So new element multiplied by n is equal to 5 plus the current element is equal to 4. So that will be giving me 19. 5 there is a 15 plus 4, that will be 19. So over here 19 will be stored. Now 19 is present. So let's move to the next index, and new element is nothing but empty now. For the next index, what will be the value of new element? That is array of I. Current element is 0. So now at the 0th index, what is the value present? It is equal to 19. So over here you can observe this is not the original value which is present at the 0th index. It is somewhat a combination of new element and the original element. So from this I need to fetch the original element that is actually present at the 0th index at the time of input. Okay, and in order to find the first value, what was the equation? We already saw, in order to find the first value, we simply need to apply modulo n. So same thing will be done over here. In order to fetch the value, I will add one more thing, that is new element will be nothing but modulo n of this. Okay, so now I will be applying modulo n. So 19 modulo 5. So 5 3s are 15 and 4 will be the element. So 4 is actually the original value which is present at the 0th index. It is actually the original value. So new element will be equivalent to 4, and now what I will be doing? I will be finding the combination of this equation. I will be solving this equation, that is new element into 4 into n. So new element is equal to 4 over here, and multiplied by n, that is 5 plus the current element. So current element is equal to 0. So 5 4s are 20 plus 0, that would be 20. So now at this index 20 will be present, right? So moving down towards the next equation, the next index. So the next index is index number 2. So for the index number 2, I need to find the new element. So new element is what? First of all, let's put the value in this equation. So new element, current value is equal to 2. So array of 2 is equal to 2 modulo n. Modulo n gives you 5. So 2 modulo 5 will be equivalent to 2. So 2 is my new element, and now what I need to do? I need to store both the values inside the index number 2. So new element multiplied by n plus the value present at the ith index plus 2. So So that would be equivalent to 12. 5 2s are 10 plus 2, 12. So now over here 12 will be present. So moving down towards the next equation, the next index. So again finding the new element. So new element is nothing but currently I can see 1 present. So let's see what is the value present at the index number 1. At the index number 1 I can see 20 and apply modulo n to get the original value. So modulo 5 will be giving you 0, and at the index number 1 originally 0 was present at the time of input. So our new element is nothing but 0. Now let's store 0 at this index. So that would be new element multiplied by n plus the current element. So I will be getting 1. So 1 will be present over here. Now what else we need to do? Let's find the same thing for the last index. So the last index, current element at the last index. So let me change the color of it so we can understand that this was already filled, right? So for the last element, current element is equivalent to 3, and what is the value present at the index number 3? I can see 1 is present. So 1 modulo n, that is 1 modulo 5 will be giving me 1. So this means 1 was originally present at this index number 3. So new element is 1. So now let's store this 1 at the index number 4. So that would be new element multiplied by the value n. So that would be 5 plus current value. So current value is equivalent to 3. So 5 plus 3, it will be equivalent to 8. So now 8 will be placed over here. So I can see 8 being placed over here. So now at each and every index inside this input array, I have stored two different values. The values of the transformed array and the values of the original array as well. So now I need simply the values of the transformed array. So that means I simply need the second value. I need the second value, that is the new element. I simply need the new element. So second value means nothing but the new element. So new element can be simply fetched by dividing the value by n. So at each and every index I will divide the value by n. That means the division is going to be integer division. Okay. So 19 divided by 5. So let's find out the value for each and every index. So 19 divided by 5, that will be equivalent to 3. So 3 will be placed over here. So now 3 will be placed. So 20 divided by 5. So that will be giving me 4. So at this index 4 is the new value, that is the value for the transformed array. Now again 12 divided by 5, that will give me 2. So 2 should be the value for the transformed array. Now the next index is 3. 1 divided by 5, integer division will give me 0. So 0 is the value for this index. And now 8 divided by 5, that will be equivalent to 1. So 1 is the value for the transformed array. And this is my entire transformed array. And we can verify, that is 34201. You can see over here 34201 is the output. So in this manner we can transform the given input array into a completely new array without using any kind of extra space. Over here what were you using? I was using nothing, right, in order to transform this array. We were simply using this equation. So let's write down the algorithm so that you can implement the entire code in coding part in other languages as well. So for the algorithm, first of all, what else do we need? We need to iterate over all the elements of the input array. And we need to store the new element at each and every index along with the original element. So basically for each and every index, first of all I will be finding the new element, and for finding the new element, the equation was array of I, right? And I was applying modulo n because we don't know that whether two values are already present at that index or only a single original value is present. So modulo n needs to be applied. So all the cases will be covered up, right? And after doing so, I need to update the value at the current index. So current index contains array of I. So the value will be nothing but new element multiplied by n plus what? plus the current value. So current value, that means the original value which is already present. And now this for loop will complete the task of storing two values at each and every index, that is the original value and the value for the transformed array. And now I simply need to remove the original value and I simply need to keep the transformed array values at each and every index. So again a loop will be required, right? So I will be again iterating over each and every index from 0 till I, and I is lesser than n. And for each and every index I need to remove the values of the original array. So I will be simply dividing this value by n. So array of I is equal to array of I divided by n, right? And this is the entire logic which I need to fill in the function, and the rest of the part of printing the array will be taken care of by the driver code. I hope you were able to understand this algorithm, and if you face any kind of difficulty, do mention down in the comment section as well. Okay, so now we can have a look at the coding implementation part for the same. So I'll be coding the entire algorithm in Java, but you can implement the same thing in other languages because it's very easy to understand. There are simple loops and simple equations required, right? So basically in that manner we can implement it. So let's so this is the function or method which we need to complete, and the argument passed over here is long array and the value of n. So n denotes the size of the array, and that is what we require, right, in order to multiply. So now the first for loop is required to store two values every index. Okay, so I'll be iterating from I is equal to 0 to I is lesser than n. And now what else I'll be doing, and inside this also we need two different values. First one is the new element, so I'll be creating a variable that is called new element. And what is the new element? So new element is nothing but array of I, right? And we are not sure that whether two values are already present or one value is present. So I'll be applying modulo n, and modulo n will be always giving me the original value, that is the first value at that index. Now I need to update the value at this current index, so that is nothing but new element multiplied by n plus the value which is already present. So now I have stored two values, transformed array value and input array values. Now I need to remove the input array values. Removing input array values from each index, from every index, right? So I will be iterating, again iterating, I is equal to 0, I is lesser than n, and I plus plus. Now I simply need to divide the element by n in order to keep the transformed array values, right? And this is the entire coding implementation part. Let's try to compile and see what we are getting, right? Okay, so over here, this, as we are coding in Java programming language, I need to give some instruction regarding this. So whenever you are using long data type array, or let's say you are using array, so in Java it is compulsory that the index should be in integer only. Okay, so that is why you are getting this kind of compilation error. The compilation error is for this line, that over here I am using array of I as my index, and index should be of integer data type always in Java programming language. And now let's again compile and run, and will not get any error right now. And the compilation was completed. So let's try to submit and see the acceptance. And we can see that the problem was successfully submitted, right? So basically, if we try to observe the time and space complexity, what do you think, what will be the time and space complexity? So there are simple for loops required, right? Here is our first for loop that runs from 0 till n, and 0 till n minus 1, and the next for loop runs from 0 till n minus 1. So two different linear loops are required to solve the entire question. So basically overall the time complexity comes out to be order of n. And what about the space complexity? We kept in mind that the question itself says that we need order of 1 extra space. So we haven't used anything extra, right? So the space complexity is also being fulfilled. So expected time and space complexity are satisfied. So that was the entire solution part and the implementation part for the question rearranging an array with the order of 1 extra space. I hope you understood the algorithmic part and the coding implementation part. And if you have any kind of doubt, do mention down in the comment section. I will reply over there. And best of luck for the upcoming problem of the day. I hope everyone are able to solve each and every question. So that was it for today's video. I hope you really enjoyed the video, and if you really enjoyed the content, then do like and share it with your friends if they are looking for the same kind of content, and do subscribe to this channel if you want to watch such an interesting content, right? Thank you everyone.